Hello friends, I welcome you all to this session on power plant engineering. So in the previous lecture, you have seen the impact of increasing the boiler pressure on the performance of Rankine cycle, and you have observed that as you increase the boiler pressure beyond a certain limit, then the dryness fraction at the exit of turbine drops very drastically, and which is very dangerous for turbine blades. So now to increase the boiler pressure and to limit the dryness fraction at the turbine exit, what we do is we perform reheating of steam. So reheating means to again heat the steam. So let us first make one schematic so that we can understand it better. Now consider this is your furnace, then boiler. Then from boiler at state 1, let's say, steam enters into a high pressure turbine. So here we will be using two turbine expanding twice. And then first primary expansion happens, then after expansion steam is brought back to the low pressure, steam is brought back to the furnace, and then it is then expanded into another turbine, which is your low pressure turbine. So this is, let's say, state 3, and then after the expansion it is condensed, then it is pumped back to the boiler pressure, and that's it. So if this state is 4, this is 5, this one is 6. So this is your reheated Rankine cycle, and this is your reheater RH. Now if you try to draw the TS diagram for it, then this is your boiler pressure, and let's say this is the condenser pressure. So somewhere here you are at point number 1. Then expansion happens, but it happens only partially, so that the steam remains in the superheated region slightly, and then from this pressure, let's say, from this pressure it is again heated. Now this is state number 2, and now it is again heated to the same temperature. Let's say it is state 3, and then it is expanded. Now you can see that it is right now in superheated state because the diagram was not perfect. So if I draw the perfect diagram for it, try to draw at least. So this is state number 1, expanded to, let's say, this point, and then this is that pressure. Okay, and then you control Z, then you further heat it up to, let's say, point number, this is 2, then this is 3, and then you expand, then you will be arriving at point number 4. So this is basically your point number 4. Then 4 to 5 it is condensation process, and then 5 to 6 it is pumping. So this is the one, and that's complete your reheat Rankine cycle. So here the catch is, if you would have expanded the steam, then the dryness fraction here, if this is 4 prime, let's say, so it will be x 4 prime. Whereas due to this reheating, what has happened, you are able to get dryness fraction more at the exit of turbine in comparison to the dryness fraction what you could have obtained with direct expansion in single turbine. And due to this, you have done two things. Not only you have increased the dryness fraction, but you have also increased the work output. Previously, this was your work output from 1 to this 4 prime. So now you are extracting the work till point number 2, and then from 3 you are extracting the work again. So due to reheating, not only the dryness fraction improves, but also the work output increases. So this is very much important to understand here. Also, you are heating it again, so the heat input will also increase slightly. Now you can argue whether efficiency has improved or not. So we cannot guarantee. The improvement in the efficiency can only be understood or told once the mean temperature of heat addition is evaluated. Okay, so let us try to do some analytical work. Let us try to evaluate what the turbine work output is. It is basically the work output in the high pressure turbine, work output from high pressure turbine, plus the work output from the low pressure turbine. So what is the high pressure turbine work output? It is H1 minus H2, and from low pressure turbine it is H3 minus H4. What is the pump work? It is more or less the same, that is H6 minus H5. The heat input to the cycle will be in this portion first, that is H1 minus H6, as well as in the reheater, that is H3 minus H2. And the heat loss, that is Q2, will be H4, that is from here to here, H4 minus H5. And about efficiency, it is the net work output upon heat input. So net work means work of turbine minus pump. So it is H1 minus H2 plus H3 minus H4, that is the turbine work output, minus the pump work output, that is H6 minus H5, whole divided by the heat input, that is H1 minus H6 plus H3 minus H2. So in this way, you can work with your reheated Rankine cycle. So what benefit you have got? The first benefit is the dryness fraction at the exit of the turbine has improved, and at the same time you are also getting more work output, but you have also supplied more heat. Okay, so in this lecture, till this point only. In the next lecture, what we'll do is we will try to use Excel to solve one problem of reheating, and at the same time we'll try to understand the optimum reheat pressure, so that you can understand that what should be the limiting pressure, so that the over expansion in the low pressure turbine doesn't happen. So thank you very much for watching.